So this is another question related to Newton's law of motion, which deals with the inclined plane again. But in this one, we're having two objects, two blocks. Here it says a ball of mass M1 2 kg, M1 2 kg, and a block of mass M2 10 kg are attached by a lightweight cord that passes over a frictionless pulley of negligible mass, as in the figure. The block lies on a frictionless incline of an angle 30 degrees. Theta is 30 degrees. Find the magnitude of the acceleration of the two objects and the tension in the cord. So we have to find two things, acceleration and the tension in the cord. Well, here is the free body diagram. This is the driving force, M2 g sine theta, which is related to this one. And this is mg, which comes down straight forward, which is perpendicular to this horizontal line. And this is the adjacent force to the angle M2g cosine theta. And there is a tension in the rope here. And for the hanging object, which is M1, we're having M1g is downward and tension is upward, and the acceleration is going to go upward. Okay. Let's write the formula for M1. Since here acceleration is upward, we're going to take upward to be positive, because we usually take the direction of motion to be positive. Take upward positive. So we're having T minus M1G equals M1A. This is equation number 1. And for the second mass, which is this one, the acceleration is going down. Therefore, we're going to take downward to be positive. Of course, this is for M2. All right, so we're going to say driving force, which is M2g sine theta, and then there's an opposing force, which is T minus T equals M2A. And this one is equation number 2. And now we're going to add equations number 1 and number 2. Here is positive t and here is negative t. They fade away. So the t's will go away. And we're left with the driving force, which is M 2g sine theta. It's here. Minus M1G, which is this one, equals M1A A plus M2A. So A in this case, and this one, we can take A as common factor. A is going to be common factor. We have M1 plus M2. Therefore, A equals M2G sine theta minus M1G divided by M1 plus M2. So A is going to equal M2 G sine theta, which is 10, and we said we use 10 for G for convenience, and then sine 30. Minus 2 times 10 divided by 2 plus 10, which is 10 into 10 is 100 into sine 30, which is 0.5, is going to make it 50 minus 20 divided by 12. So 30 divided by 12. 30 divided by 12. It's 5/2. Which is 2.5 meters per second square. This is the acceleration. And now we can find tension using equation number 1, which is T minus M1G equals M1A. T minus M1G equals M1A. Therefore, T equals M1A plus M1G. We can take M1 as common factor, A plus G. So T is going to equal 2, which is M1, and then this is 2.5 plus 10. So we're having 2.5 plus 10 is 12.5 times 2 is 25. Therefore, T is 25 Newton.